Welcome to Prescriptive Duct Seal Certification Training. This is Module 1. There'll be 5 modules. Module 1 is Introduction to Prescriptive Duct Sealing. The desired outcomes from this training is that you will be confident and that you'll understand the program requirements, how you can talk to homeowners about the benefits of duct sealing, and hopefully identify duct repairing sealing opportunities in site-built and manufactured homes in a way that fits with your business model. Also, if you're not accustomed to sheet metal tools, there is a module that goes through the basics of the most popular sheet metal tools. As mentioned, there will be 5 training modules. Module 1 covers the introduction to prescriptive duct sealing. Module 2 covers the tools of the trade. Module 3, site-built duct sealing. Module 4 will dive into mobile home duct sealing. Module 5 covers combustion safety, participation, rules, and paperwork. We will cover many topics today. But first of all, let's talk about why we seal ducts. Sealing ducts ensures conditioned air gets to its intended destination. That's inside the house, not the attic or the crawl space. And we want to do that in an efficient manner and one that also produces the maximum amount of comfort for the homeowner. This module will highlight the program consideration, components of a duct system, and how to properly assess duct condition. It's not always as easy as it is on first sight. And then also steps to sealing a duct system in an efficient and hopefully profitable way. Let's move to program considerations. What is prescriptive duct sealing? It is a prescriptive way to repair and seal ducts. What does this mean? It means that you must mechanically fasten all joints before sealing. If you do not mechanically fasten the joints, the mastic will eventually crack and the leaks will occur again. You have to seal with mastic. There's only a few cases the program allows you to use an approved tape. Once again, I want to point out that tape is neither a fastener or a permanent sealant. If you don't believe me, just talk to the old folks before they had screw guns and they had to put ducts together with screwdrivers and hand drills. We have screw guns today that make screwing together duct systems much easier, and there is no reason not to do it. We've covered what this program is. Let's talk about what it is not. You will not be using duct blasters or blower doors in this program. It is prescriptive. It is not performance. There will be no test that you have to do in order to qualify homes for this program. Let's talk about the difference between PTCS and prescriptive duct sealing. PTCS duct sealing involves pre and post duct leakage testing. It also requires that you remove a certain percentage of duct leakage from the duct system. Prescriptive duct sealing, on the other hand, does require no testing. However, all other sealing specs are required, and just with PTCS, you must seal all opportunities. Please check with your local utility. They may or may not offer an incentive for prescriptive duct sealing. If you write down one website today, please write down ptcs.bpa.gov. All relevant specifications can be found at this site. Specifications are covered there, and as the slide shows, it also carries a Spanish version, which can be very useful. We all know that most existing duct systems leak. How much do they leak? The table below shows the results of a detailed co-heating test that was conducted on a group of energy-efficient homes in the Northwest. The blue bars represent homes with ducts outside the conditioned space. The numbers associated, whether it's 62.5 or 56.7 or 73.5, what that represents is the percentage of the heat energy leaving the heating system, in this case an electric furnace, and actually usable by the house. You can see there's a lot of D's and low C's involved there. Notice on the 2 green bars on the far right, these were basement homes and all the ductwork was inside the house. Yes, the ducts still leaked, but they leak to conditioned spaces. If you will, they're mini diffusers. This is why the program really only allows for duct sealing to get an incentive if the ducts are located outside the conditioned space. Some benefits do occur if you seal ducts inside the space, such as maybe some combustion safety issues, and also getting more conditioned air to a particular spot. This table shows the same information in a different way from our previous slide. It shows the before duct sealing and the after duct sealing numbers, and again, this is the percentage of the heat energy that leaves the heating system that is actually usable by the house inside the conditioned space. The far right category, the percent increase 12, 32, 3%, 11%, 17%. All these really are pretty dramatic. Many of your companies probably sell air conditioners and heat pumps based on that efficiency. As you can see, duct sealing often increases the efficiency more than, say, going from a 8.2 HSPF all the way up to a 10. Duct sealing is important, and it will make your customers even more impressed with the energy savings that you deliver. The eligibility rules to participate in the program are really quite simple. First of all, once again, we're going to just say that before you do any work, please contact your local utility. There are differences between how different utilities deliver this program. Generally, duct sealing applies to homes heated by a forced air heating system. That would be either homes heated with an electric furnace or a heat pump. Homes with forced air electric systems supplemented by ductless heat pumps and zonal heating are also allowed. Just one more rule. As mentioned in previous slides, it's only sealing ducts that are outside the conditioned space of the house that results in actual energy savings. As a result, to be eligible for this program, at least 30% of the ducts must be in unconditioned spaces. The following areas are defined as unconditioned spaces: crawl spaces, garages, and attics. Many times it can be confusing to call a basement inside or outside the conditioned space of the house. These are some basic guidelines to help you. Inside the house, again, you don't get to seal ducts that are inside the house for this program. If the basement is a living space, it's got bedrooms or living room or family room down there. If it has return or supply registers and no insulation between the basement and the conditioned space above, that would make the ducts inside and not eligible. Outside is more or less the opposite. It's not used as a living space. There might be a washer or dryer down there, but it's clearly not used on a full-time basis. There'd be no return or supply register in the space and insulation between the basement and the conditioned space above, making it truly outside the house. The prescriptive duct sealing program does not allow the duct sealing of any home that contains an unvented combustion space heater. Unvented combustion space heaters can take many forms. They can range from good-looking, nicely modeled gas fireplaces to salamander heaters to camp stoves to kerosene heaters. What you need to remember is that duct sealing is not allowed in homes that contain unvented combustion space heaters. Next, we're going to move to the components of a duct system. This is necessary because, well, let's face it, in our industry, the same thing can have different names, and if we all use the same language, our communication will be clear. These are some common terms that are used in our industry. Adjustable elbows, those are the 90s. You can make into a 90 or a 45. Really handy pieces of sheet metal to put together a duct system. The part that rotates between the different sections are called gores, and evidence suggests that they do leak and do need to be sealed in this program. Crossover, it's usually referred to that crossover duct that connects side A of the manufactured home to side B. It tends to be unique to manufactured homes. End caps, that's a section of sheet metal that terminates a section of duct, such as a panned return. We have found homes missing those end caps. Grills, registers, and diffusers, sometimes called GRD, that's the part of the duct system that the homeowner sees. That's where the air goes in if it's a return and where the air comes out if it's a supply. Pan joists, they can be very difficult to seal, and we'll cover them later. It's a building cavity, such as the space between floor joist and the floor to convey air. The pan refers to the flat sheet metal that forms the bottom of the duct system. Plenum, that's the main supply duct that feeds the branch runs. Takeoffs, that's any section of ductwork that takes off the plenum. What must be sealed? The basic tenet of this program, if you can reach it, if it's accessible, you have to seal it. What parts do you really have to seal? All boots must be inspected and attached to the subfloor. The plenum must be sealed. All takeoffs must be sealed. All gores on adjustable elbows. The air handler itself, and of course all disconnects and slip joints between sections of sheet metal ductwork. Just like any other job or task, it is best to come up with a plan first. Next, we're going to talk about how to assess the duct condition. Before jumping into the crawl space or climbing into the attic, it's a really good idea to do that initial inspection. What you're doing in that initial inspection is you're deciding what the major problems are. and decide if duct sealing is really enough. If the duct system is in really pathetic condition, rusted out, torn up, rodent infested, it might be a good idea to bid the whole duct system and replace it. It's not eligible underneath the program. However, it is a good idea and the homeowner will get value from it. While the homeowner might not be a technical expert, they do know something about living in their house. Always start with some questions. Ask if they have rooms that are too cold in winter or too hot in the summer. And it might be, a good way to find a disconnect. Hey, I know why your master bedroom is not comfortable. It has a disconnect going to it. Or just maybe proof of poor duct design, which if that is the case, you might want to design and install a new duct system to assure comfort. Ask if they pay high energy bills. It's been my experience that people that have high energy bills or feel that they have high energy bills think they're paying a lot for the levels of comfort that they're actually getting. So do pay attention to that question. That level of frustration they have with their energy bills could be a sign that they have a really leaky duct system. A few more occupant questions. Do you notice any unusual smells when the air handler turns on? Smells such as creosote, that nice crawl space smell, garage odors, gasoline smells, just that sort of, dirty, icky, moldy smell that might be like a crawl space. That can be a clue of disconnected ducts. When you change your filter, do you notice any insulation on it? Boy, if they're getting insulation on their filter, that's a sign of a big return leak and obviously not good for indoor air quality either. Conducting that visual inspection. Again, a lot of us just like to jump in and start fixing things, but that thorough visual inspection is so important to doing a good job. Start with the inside of the house for a really obvious test. I call it the DUH test, the dumb and unbelievably humbling test, where you go to the air handler and turn in heating or cooling mode. And does air come out of all the registers? If it doesn't, there might be a damper that is shut. And if they never knew it was shut and you open it, you get to play the role of the hero. It might also be due to a disconnect. Another really simple test is when you remove the register or grill, do you see ductwork or do you just see the crawl space, the attic, or perhaps even the neighbor's cat? Here's an example of removing a register and looking down into the duct system itself. Here's the result from looking into the duct system itself. As you see no interior liner or flex duct, you see no elbow. All you see are bits of floor insulation and the ground cover on the dirt underneath the house. Obviously a problem that needs to be corrected. On the other hand, if you look down and you see the interior liner or flex duct, that's a good thing. While Mastic has been proven to be the best duct sealant, the duct sealant with the greatest longevity, it is not magic. The system must be mechanically fastened before sealing. If all we did was jam these two sections of ductwork together without putting screws through it and coat it with mastic, the next person that bumped the system would break that seal and leakage would reoccur. Most of you have spent quality time in crawl spaces and attics, and you've seen pictures worse than this. The picture on the left was from a brand new home. The boot's on there. It's ready to go in. It was intended to go to the bathroom. And my guess is that the HVAC guy didn't want to get in the way of the plumber, and he assumed that he would come back after the plumber was finished, and guess what? He never came back. The picture on the right is from a crossover connection on a manufactured home. The cat, while friendly, was not a very good helper at all. Let's take a minute to figure out how we would seal this. As you can see, the insulation is actually underneath the sheet metal takeoff. We also have some notches right here, some fins, some tabs that were not exactly folded correctly. In order to seal this correctly, we would have to take the takeoff off, remove the insulation, because insulation is not an air barrier. If it was, we would not use it for furnace filters. We would have to remove that, seal and screw down the takeoff, mastic between the takeoff and the sheet metal underneath it. In addition, we would have to bend these tabs in a more cohesive fashion, put some screws to it, and seal that. If all we did was coat this with mastic and coat this with mastic, the seal would not last long, nor would it be effective. What we're looking at is a product that was used in commercial applications where all the ductwork is inside the house and it was used for acoustical reasons. What it is, it's a mesh-lined interior flex. It was not airtight on the inside of the duct at all. Air can obviously get through it. It is impossible to seal, and any rip on the exterior liner is also a hole in the duct system. It's our recommendation that you do not try to seal these systems, but you bid a flex duct that has an interior liner. Many homes that were built before recent code changes use building cavities to convey air. Here we're looking at returns. At least they're supposed to be returns. The air can come from any number of places. These are very difficult to seal. The program does not require that you seal building cavities used to convey air. Again, we're going to emphasize look for the big leaks. We have inspected jobs over the years where all the small joints are sealed and screwed together, but we find things like this picture indicates, a big leak. In order to fix the big leak, you have to carry sheet metal, and it's those disconnects or never connects, and for some reason they're way more common than I would ever have expected. More big leaks. This is actually from a home that underwent duct sealing. It was not through the PTCS program, I can proudly say. As you can see, we have mastic here, we have mastic on all the joints, but we have a major disconnect. The door to the fan has been taken off, but you can see it's up on bricks. This is obviously a big leak. They did put mastic around the filter access, but the filter access actually has no sheet metal covering over it, leaving a big gaping hole. When ducts are covered with fiberglass insulation, it can be difficult to see if there's a disconnect underneath it. As you can see here, we have a complete disconnect that was found by this discoloration of the fiberglass bat. Basically, again, fiberglass is a good air filter, and the dirt and the grime exiting the duct system has stained the fiberglass over time. So if you're looking for leaks, one good way to find them is to look for that ghosting. After we've done our initial diagnosis, our initial inspection, and we had come up with a battle plan to how best and cost effectively seal the duct system, let's go through the steps on actually how to do the sealing. Where to start? After you fix the never connects and the disconnects and replace just the rotted out stuff, the best place to start is on the high pressure side. Basically, you can work your way out in both directions from the air handler. The closer you are to the fan, the greater the pressure in the duct system is, and the greater the energy savings will be. The supply side tends to yield more savings than the return side. Common problem areas are the Ys, the takeoffs, and the elbows. Don't seal ducts in conditioned spaces. Well, you can if you want to, but you're not going to see many energy savings from it, that's for sure. Seal the returns. Make sure you get the big stuff on the return side. Sealing the little tiny holes on it is probably not the most cost-effective use of your time. Existing duct insulation over sheet metal ducts is not considered a barrier to sealing those ducts. You must remove the insulation to access the duct connections beneath that insulation. Here is a really good example of why we don't allow duct tape. As you can see, once upon a time this connection was duct sealed, and there's duct tape on it to prove it, and it's come disconnected. And of course there's no screws put together. So Mastic wants to stick to sheet metal. It does not want to stick to any kind of existing tape. Program requirements is you make a good faith effort to remove all tape. We realize in some areas you just can't. I don't know why it's stickier than others, but please do your good faith job of removing any tape on it. That will allow the mastic to stick to the sheet metal and form a long-lasting, durable bond. We have emphasized over and over so far that mastic is the best duct sealant. The program does allow tape in a few areas. Metal tape, a high-quality metal tape, can be used on the air handler itself and the air handler to plenum connection. This is the best case scenario for them. On that air handler, you've got 2 pieces of flat sheet metal. It's generally pretty clean, and the tape can adhere well. The reason we allow it to connect to the plenum if that unit ever needs to be taken out and replaced, breaking open a joint that was sealed by mastic is very difficult and might require a Sawzall. So those are the two places that you can use a high quality metal tape. Ductwork must be supported. If it's not supported, it will sag. And we can see here, this is nice webbing, a very good way to support both flex duct and sheet metal duct. If you are using straps on flex duct, you have to put the straps closer together than you do on sheet metal. Before applying mastic, you must connect the ductwork. You must put at least 3 screws in each sheet metal to sheet metal connection in order for the mastic to form a durable seal. After the system is mechanically fastened, it is important to apply mastic. It must be thick as a nickel. If you apply it too thin, it's not going to work. If you apply it too thin, it's artwork. It's not actually energy saving work at all. As you can see here, there's a lot of mastic on everything that might leak. We've got all the gores covered over here. We've got the slip joints covered. This is a takeoff from a manufactured home. And as you can see, there's lots of mastic. That's not going to leak. If you have removed insulation for duct sealing, it is imperative that you reattach it. It is not your job to reattach insulation that has fallen off before you got there, but if you have removed any insulation, it is your job to reattach that insulation. Let's quickly summarize what we hope you've learned today. As with any job or task, it's good to have a plan before you start. Make sure you do a good visual inspection before you start. If you're bidding the job, it's so important to do that good visual inspection. You might send your crew out there to seal a duct system that actually needs to be replaced. The basic tenet of this program, if you can reach it, you seal it. Make sure there's no unvented combustion equipment in the house. And make sure you do a good job of removing that existing tape. If you don't, the mastic will not last. And from a frame of mind, you're plugging, you're not painting, and get that mastic as thick as a nickel. That ends our first module, and we hope that you watch the other modules.